Hey there, Mr. Weaver here, and this is Topic 2 and 3, Lesson 5, and Slope-Intercept form in context. After this lesson, you need to be able to write an equation in slope-intercept form within a given context, and you need to be able to identify the rate of change, which is also called the slope, and the y-intercept from context. After this lesson, you'll know you're successful if you can write an equation in slope-intercept form from context, and if you can identify the rate of change and y-intercept. First, what is a linear function? So a linear function is a function whose graph is a straight line. It can look one of these three ways and almost every slant of the line in between. So it could be slanted downward, could be flat, it could be slanted upward. But in all three of these instances, these are linear functions because the graph is a straight line. Another vocab word that you need to be familiar with is slope-intercept form. Slope-intercept form, or y equals mx plus b, is just one way that we can write an equation for a linear relationship. So to get that straight line. And each part of the equation has a specific meaning. So x is still our input, y is still our output, but m stands for your slope, and b stands for your y-intercept. Now, when we're thinking about these in the context of a problem, your y-intercept is your start value or something that remains constant in the situation. You might see it as like an extra $5, or they had to pay a fee of $3. Okay, something that's only happening one time throughout the entire problem. It's a constant number. The slope is also known as your rate of change. That is the thing that, as you do more and more x's in the problem, that's what makes your y value change. In the context of word problems, your slope or your rate of change is usually with the words per or each, or you might see that slash. When we're writing equations from context, we're going to identify our rate of change, our y-intercept, and then use those two things to write the equation. Now, sometimes it'll be easier to find the y-intercept first, sometimes it'll be easier to find the rate of change, but both of them should be somewhere in the problem. So, a river was 30 feet deep after a flood. Going back to normal, the river's depth decreased 0.5 feet per day. So, two numbers we are given. The river was 30 feet and it decreased 0.5 feet per day. Now, I also underline the word decrease all the way through the word per. That is telling me that the thing is changing. Decrease is a change word. Per is a change word. Let's start with our equation, y equals mx plus b. Our y-intercept is where does the function start? So in this case, the river started at 30 feet. It was 30. So our y-intercept is 30. How is it changing? Well, it is decreasing 0.5 feet per day. So our rate of change is negative 0.5. Okay, the negative because it's decreasing. If I plug those two things in, then I have y equals negative 0.5x plus 30. Remember, the m is your rate of change and the b is your y-intercept. It's usually the same format and the same placement of the numbers. Pause the video and try the one on your side. Here are your answers for your equation. So our y-intercept was 205. That's our start value. Rate of change, it went down 15 because she's spending. So our equation, y equals negative 15x plus 205. Next example. A post office charges a $25 fee for heavy packages plus 10 cents per pound. I have two numbers given. So one of them is our fee. That's our extra. No matter what, it's only going to cost $25. And it's changing by 10 cents per pound. We see that word per there. So every pound that I add, I have to pay 10 cents more. So in this situation, my y-intercept, my extra is 25, and it is changing by 0.1 or 10 cents. Plug those in. Y equals 10 cents x plus 25. And I could use this equation to figure out how much it would cost if I know the weight. Pause the video again and try yours. Check your answers. Third example. A new company started by borrowing $10,000. Now they earn $550 per day in revenue. So our two numbers, we have borrowed $10,000. That word borrowing gives us a clue about the sign of our number. And then they are earning $550 per day. So borrowing $10,000 would mean that we started at negative $10,000. It's not money that they have. They have to pay it back. It's not part of their total. But earning $550 would make our X value increase by 550 each time. So our equation would be 550x minus 10,000. And then what does that y-intercept mean? I already kind of talked about it. That negative 10,000 means they borrowed money, so they started with a negative balance and have to earn that money back before they can make a profit. All right, try your situation. What equation would model this situation? And what does the y-intercept mean? Pause the video and try it out. Check your answers. The word ascending means that it is going up, so our rate of change would be positive in this situation. Last example. A beluga whale was 200 feet below the surface when it began diving down at a rate of 3 feet per second. What is the equation? What does the rate of change mean? Well, our numbers that are given, 200 feet below, so that would tell me that it's at negative 200, and the rate is 3, but it's going down, so it would be negative 3. So our equation should be y equals negative 3x minus 200. And then what does the rate of change mean? Well, that is our negative 3. That's showing the whale is going down at a rate of 3 feet per second. Pause the video one last time and try your problem. Come up with the equation, and then what does the rate of change mean in your context? Check your answers. In this lesson, we learned about slope-intercept form and how that's a format for writing what's called a linear function. And we use this when we know our slope or our rate of change and the y-intercept. Slope-intercept form is y equals mx plus b, where the m value is your slope and your b value is your y-intercept. So in a contextual situation, the y-intercept tells where the function starts, or what is extra, what is staying the same every time in the function. For example, if you were in debt $500, the y-intercept would be negative 500 since you're owing that much money to start. Your rate of change would tell how much that amount is changing each time. So if you made $200 per month, the total amount of money that you have would increase $200 each time a month passes. A situation like this would be represented as y equals 200x minus 500. In most situations that we're dealing with, we'll have a start value and something that it's going to change by each time. After this lesson, do you now know how to write an equation in slope-intercept form from context? And can you identify and describe the rate of change and the y-intercept from context? If you're not sure how to do these things, go back and check the couple examples that we had to figure out how to do these things and deepen your understanding. And that is the end of lesson 5 on slope-intercept form in context.